We think that our machines solve most of the difficult engineering of fusion at a very low cost. Hello, I'm Michel Laberge. I'm the founder and chief scientific officer of General Fusion. One of the big problems with fusion is the energy comes on very fast neutron. Most machines are made out of metal or something, and when the neutron hit it, it moves the atom in the crystal and it disaggregates the metal. So the metal after a while fails. So this is a big problem with fusion because the machine gets broken. People want to invent a new type of metal that will resist that, but this is a big job and it's pretty slow. At General Fusion, because we have this liquid metal all around the machine, the neutron hit the liquid metal, the atom in the liquid metal, they're already kind of loose. So when you hit them with a neutron, it doesn't break anything. So we don't have it's called the first wall problem, where the neutron match the machine. Another advantage of the machine is that the tritium rebreeding. So we always say that we're going to fuse hydrogen, but that's not exactly true. The easiest fusion happens with deuterium and tritium. Deuterium is one proton with an extra neutron. It's stable. 1 part of 5,000 of all the hydrogen in the universe are deuterium. So if you look at the ocean, H2O, there's lots of hydrogen in there. And 1 part in 5,000 is actually deuterium. So we extract the deuterium from seawater on the form of actually AV water. You might have heard the term before. So deuterium is no problem. However, there's no natural tritium. So this is great. We're trying to use fuel that don't exist. So we have to rebreed it, make our own fuel. And this is done by the neutron coming out of the fusion hit some lithium. Now our liquid metal will have lithium in it. And when you hit the lithium, it breaks in two, makes an helium, which you let go, and a tritium, which you put back in the machine. Our big advantage is we covered all the machine, totally covered with lithium all around it. We have all this liquid to absorb the energy, and we can easily flow this liquid into the steam exchanger to make some steam and things. Other people have to add that as an add-on. But here we have naturally an easy way of extracting the heat out of the machine to run this turbine. So that's quite advantageous. Well, one of the big advantages of magnetized target fusion is that we use both advantage of the magnetic field and of the compression. So we use both advantages to make something that's simpler. So the magnetic field prevents the particle from escaping, so we can compress slower. And during the compression, the plasma gets denser and hotter. And a denser plasma, the atoms crash into each other more often because it's denser. It makes more fusion faster. So you don't have to hold it so long to make enough energy to pay for the energy that you put in. So you can make the plasma last less time. And that's a big deal because when you try to put plasma together, it wiggles and it jiggles and it's trying to escape quite badly. We have the fact that any fusion you do, you're going to have to throw a lot of energy to heat up the thing. Typically, this is done with superconducting coil, laser, or other expensive equipment. Our energy comes from simple piston, so it'll be less expensive. So we think that our machines solve most of the difficult engineering of fusion at a very low cost. And that's why we think it's a good idea.